today we're going to learn about how nearsightedness works. So nearsightedness happens, it's also called myopia, when you can only see what's really close to you and you have a really difficult time seeing what's really far away from you. In other words, your eye can't focus at infinity at a really far distance. So how does this work in terms of actual lenses? Well, so your eye actually is a convex lens, meaning that it's going to be causing rays of light to come in, and if this is the retina back here, the rays of light are going to converge. They're going to intersect at this point, and that is where the light is ultimately focused. But what happens is that if you are a person and you have myopia or nearsightedness, the same thing doesn't happen. Instead, when parallel light comes into your eye at infinity, the light is going to focus a bit too early. So before it actually hits the retina, which is a problem, meaning you're not going to actually see the light to the same extent. So how do we actually correct myopia or nearsightedness? There are many types of lenses that are used, but the most common way to do this is to use a corrective lens or a diverging lens. So this is a diverging lens. And like the name implies, instead of making the rays of light converge, the diverging lens does the opposite. So when the rays of light come in, they'll diverge a bit. They'll go out. And again, this is the corrective lens we're putting in. So by making that light go out a little bit extra, that way, when the eye, which still has the nearsighted problem, when it converges the light, it's going to converge them back here. So now, just like it's supposed to, the rays of light do in fact converge and hit the retina. So we saw that in this situation, because a nearsighted person had light that was being focused too far away from the retina, we added a diverging lens, which is shown here in blue. And what that did is to first diverge a little bit out, and then converge, and finally hit the retina on the proper spot.